In today's episode, we're going to go over simplifying polynomials, aka combining like terms. We just went over evaluating expressions. All right, that was the video prior to this. That's just giving you an expression, an algebraic mathematical expression, such as this: 3y plus x. And then they had on the side, they would give you what x and y was. X and y is 3, let's say, and y is -2, let's say. And all you had to do was get those values of x and that value of y and put it into its designated spots. Always memorizing the rule that before you dump it into that spot, you need to rewrite the problem with parentheses in place of all those letters, and then put your answers in. That's what we went over. Oopsie, and I already made a mistake. The -2 was supposed to go here, and the 3 there. And then you would dump that into the calculator, and boom, 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 you'd come up with a solid whole number or a decimal number. It didn't matter, but the calculator would dish out an answer for you. Here's the thing, my friends. No matter how long the expression is, you would always get one answer. Let's pretend this one was the answer 15. I'm just making that up. That's because we were given the value of those unknown numbers right there, right? They gave it to us in the side, which, by the way, like I said, on the GED, they might not give it to you like this. They might give it to you in word problem style, right? They might say, Neil, we can make one up very quick, even though this is from the prior video. It always helps to, redo stuff in the head. Let's say Neil bought a PS5 at the value of 2x, right? And Pedro bought a Xbox at the value of 6y, right? And then they say, what is the total amount of money they spent, Pedro and Neil, if x represents 200 and y represents 50, right? So they give you something like that, but they won't give it to you on the side there like I just did. I just wrote that for my own sake. They'll give it to you in that word problem style that I just said, that I just blatted outside, right? So it's up to you to read it and be like, oh, x represented 200, y represented 50. They already gave us the expressions of those. They said, what is the total amount? That means addition, which means I know I must do this. And then whatever the calculator gives me, boom, that'll be the total amount of money they spent together. Kind of tough, I know. But that's why we got to always do worksheets and always ask for help, y'all, because this is math. But whatever, you're always going to get a solid answer. When it comes down to simplifying polynomials, we're not going to get a solid answer. It's in the word itself, simplifying. Simplifying, evaluating expressions means to solve, technically, right? Simplifying doesn't mean to solve. Simplifying just means get your long expression and make it just a little less long. Make it just a little simpler for us. So all we're doing here is getting algebraic expressions, aka polynomials. Polynomials is just this. Let me just explain it to you, not explain it to you, but show you in a simple way. What is this right here? A number, right? What is this right here? A polynomial. Isn't that easy to memorize? Whenever you see just a number, you guys got to be like, oh, that's just a number. Whenever you see a number with a letter, you got to be like, oh, that's a polynomial. So all we're doing is getting our expression filled with polynomials, and we're simplifying it. That's what we're doing today. So now you're ready to learn the keys, the little tricks, little tips on how to simplify polynomials. You're going to enjoy this a lot. Trust me. Caution first, y'all. In the worksheet, you will need to use the skills that I taught you in the algebraic expression video. If you have not seen that, go look for it. The algebraic expression. There, I explain how you're going to use your keyboard to write out algebraic problems. So if you recall, that means if you, on the worksheet, you need to write the answer 3 squared. How are you going to do that on the keyboard? You're going to do 3. Let me just do it one more time. That means we're going to do 3, and in my case, shift 6, because whatever button you need to make that little caret sign, you need to do that, and then 2. All right, and then remember, you have to, if you find any square roots, you have to copy that little symbol. I'll make sure to attach it here, but please go look at the algebraic expression problem in order to, or video, in order to get a little lesson on that. It was at the beginning of the video, so that's good. First things first, you need to know you need to master the like and unlike terms and differentiate the two. That just means this. 3, and let's say we're given 3, and let's say we're given 4. These, my friends, are like terms. Why are they like terms? What does like terms even means? It means this. Like terms just means your two, I don't want to say numbers because we're dealing with not just numbers, but we're dealing with polynomials, but think of it like your 2 or maybe 3 or 4, it doesn't matter, your terms, your items. This is one item and this is another item. We're going to just deal with 2 for now. But looking at your 2 items, your 2 terms, are they like? How do you determine whether they're like? It's whether your terms, this one and that one, have the same letter, and same power. What do you mean by that, Neo? I don't see a letter here and I don't see a letter there, nor do I see a power on those letters because there is no letters, and I'm just like, well, then they're like terms. If we look at it more like this, if we look at a different example, 4x and let's say 6x, are these like terms? Ask yourself, the 2 terms that are given, do they have the same letter and do they have the same power? Well, this 4 has an x, this 6 has an x. I don't see no powers. Well, if you don't see, if they are both matching no powers, then they have technically the same power. So these are like terms. We're going to go through a couple more examples just so you could get it. Let's look at this one right here. Let's go with 3. All right. My 2 terms, what do you see? Negative 3x cubed, 12x cubed. Do they have the same letter? This one has an x, this one has an x, this one has an x. Okay, we're good there. But do those letters have the same power? Well, this x has to the power 3 and this x has to the power 3. Guess what? This is like terms. I don't know what that was. But what did that negative matter, Neo? No, the number never matters, all right? The negative 3 and the 12, they're just numbers. The 4 and the 6, they're just numbers. It doesn't, the number never matters. They might be negative. They could be fractions. They could be decimals. The number never matters. You're just looking whether your 2 terms have the same letter, and if those letters have the same power. That is all we're looking for, my friends. Let's look at more examples here. Let's turn it up a notch. 5, x, y, 4, 3, z. And then like term or unlike terms. This term here, that term there, are they like? Well, I see x, y, z, x, y, z. They're all matching the same letters, but do each of those letters have the same power? This x to the power 3, that x to the power 3. This y to the power 4, that y to the power 4. This z has no power, this z has no power. So it's like terms. By the way, I'm going to tell you this right now. Even though I'm saying they don't have like terms, or even though those z's I keep on saying don't have any powers, they do. from this point forward, now I already said this in a couple of videos back, but a variable, a standalone variable, is always to the power of 1. It's just invisible is all. That's going to be key in the next video, trust me. But for now, it's going to be invisible. But you should know a standalone variable is always to the power of 1. One more example, because we're not even through the whole simplifying polynomial process, but this is to get this burned into your brain. Let's go with AB, 3AB squared, and AB squared. Are these like or unlike terms? Well, I see this term here with 3AB squared and this term here just AB squared. Do they have the same letters? AB, AB. Do the letters have the same power? This A is to the power of 1, that A is to the power of 1. This B is to the power of 2, this B is to the power of 2. Yes, it's like terms. But this one doesn't have a number. My friends, I just told you the number doesn't matter to determine whether something is like or unlike terms. You're just looking whether the terms have the same letters and if those letters have the same power. But caveat, there is a number here, a 1. That's going to be extremely important today in this lesson. So this is the other thing. Not only do you have to worry about the 1 up top for the power, and you should know this by now because I did say this in another video. Whenever you see a term with no number, you should know there's a 1 in front of that term, okay? What about this? One last example, well, a couple more examples, but now we're switching it up a bit. A, B, C. Like or unlike terms? Well, I see the same letters A, B, C, A, B, C. Do each of those letters have the same power? This A is to the power of 4, this A is to the power of 4. This B is to the power of 1, this B is to the power of 1. This C is to the power of 2, this C is to the power of 3. Those C's do not match. This, my friends, is the first example of an unlike term. Does that make sense, my friends? Why does all this like and unlike terms matter? So on the worksheet, the first 20 questions, all you're doing is this. They're going to be giving you 2 terms and they're going to be asking you, they're going to give a little space. In the worksheet, there's a drop-down menu. You drop down, it's going to give you the option like or unlike, and you choose whether the 2 terms are like or unlike. All right, that's the worksheet, the first 20 questions. But why must you master the whole like and unlike differential? Why must you be an expert at that? It's because of the process of simplifying, aka combining like terms. Here's the thing. How's it going to look like on the GED? A question or after the first 20 questions on your worksheet, what else are you going to have to do? This is what you technically are going to be given. You're going to be given operations. You're going to be given expressions of polynomials. So you're going to be given, let's look at this first example here in the worksheet. 4y cubed plus 2x cubed minus 7y cubed. Here we have an expression with polynomials, right? I see 3 terms. Remember, did I say this at the beginning of the video? I don't know, but terms are the items, right? This is one term, this is another term, and this is another term. So what could probably help you to distinguish where your terms are at is just the operations. If you see a plus or minuses or any other symbol, separates terms, okay? But I do not ever want you to think that this 4 is separate from this y cubed. No, no, no. This is one whole term. This is another whole term, and this is another whole term. Now that we got that out of the way, here we have 3 terms. And we are told to simplify this polynomial. How do we simplify? This is the technique, my friend, and this is where we're going to do math. This is where we're going to do operations. So, the key is always start off with the first term, right? And what you're going to do is, the way I teach it is using shapes, just because it helps students. Eventually you're going to wean off of the shape and you're just going to immediately be like this, that, right? But all we're technically doing is finding all our like terms within the expression, and then we're combining them. How do we combine them? Whatever the operation tells us. So this is what I tell students. Always start with the first expression. Put a circle to it. What you're going to then do is go along your expression and find that guy's friend, his like term. Well, this term right here, this is not its like term because this has an x and this one was a y, right? So then you move on to the next term. This is a y cubed. The original one was a y cubed. I found its like term. So what you got to do is put a circle around that term. Here's your first tip. You do not just put a circle like this. You put a circle and always include the symbol to the left of a number, because that'll be key with the combining like term process. This is what we do. That's the end of the expression, right? This one's a loner, my friends. This one has no friends. If we put a different shape, there's no other terms around, so that you're just going to drag down to your final answer, right? These are the key ones. We have to combine this. We have to combine like terms. How do we combine it? It's easy, my friends. If you did your shape correctly and you always include the symbol to the left, this one didn't have a symbol, but it's up to you to know that there's a plus there. It's a positive 4. All we got to do is let the symbols tell us what we got to do. I see a 4 here, minus 7. What is 4 minus 7? You should know this, but if you don't, it's fine. Take out the calculator, because on the GED you will have a calculator. So take out the calculator. If you don't have the calculator, please go watch the how to download the GED calculator on Canvas. Look at the video. Make sure you download this, my friends. So all you got to do is 4 minus 7. That's all you got to do. All right. Enter negative 3. Negative 3. What do you do with the whole y cubed? Do you do anything with that, Neil? No, you just bring them down. They combine. The 4y cubed and the negative 7y cubed, they just combine. You do nothing with the exponents. You don't do anything with the letters. You just bring them down. And those two have been combined. And then again, this was the loner here, right? It just gets brought down to your final answer, plus 2x cubed. So we just got a 3-term expression and we simplified it down to a 2-term expression. That is what we're doing here. We are simplifying. Let's do another one. Another one. This one's going to be a long one, but it is an example of just how long the GED can make them, and it doesn't matter how long it is, because what you'll notice is it's actually super easy, especially with the techniques I just showed you. Always start with the first expression, put a shape around it, right? 7x to the power 4. Go along the expression and find its buddy, its like term. Where's it at? Could you spot it? Boom. Like I said, always include the symbol to the left, because that tells you what your calculation is going to be on your calculator, right? Move on. Put a different shape on the next expression. I'm going to put a rectangle there on my negative 13x squared. And what you're going to do is put a rectangle around its like term. Where's its like term at? Do you see it? Do you see it? Do you see it? Do you see it? Boom. It's this one right here. Put a different shape. Let's say a triangle, if I could fit it. Boom. Where's its like term? Positive 5x. Do you see its like term? It's only between these two. Which one is it? That is correct. This one right there. The other x. And we have a little loner there. Not a big deal. Those ones just drop down to your final answer. So, what do? We just start combining like terms. I see 2 circles here. I'm going to combine them. How do we combine them? The operation is key of your numbers. I'm going to do 7 plus. What's my number? I don't see a number here. What's the number? Y'all should know this. It's a 1. 7 plus 1. 1 plus 1. 1. 1 plus 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 1. So all I'm doing is 7 plus 1, which comes out to being 8. And then you just bring down the like term, x to the power 4. Those ones are done. Move on to your rectangles. Negative 13x squared plus 2x squared. What do we get here? Just look at the numbers and symbols. Negative 13 plus 2. Negative 13 plus 2. Take out your calculator. Negative 13 plus 2. Enter. Negative 11. So then you come here and you're just like negative 11. Don't forget to bring down the like term. X squared. Boom, boom. Do you see? Do you see? I know you see. Positive 5x plus, what's my number? 1x. So you just ask yourself, what's 5 plus 1? You could take it out the calculator if you want. I don't care. Just always use the calculator. But you guys probably already know it. It's a 6. Something I did not explain, but like in this case is a good example. What symbols should be there in between each term? It's whatever the answer is. For instance, the one prior, the negative 11, it gave me a negative 11 here, which is why I put a negative sign there, or a subtraction. They're both the same thing. In this case, positive 5 plus 1, if it helps you to visually see it, if I were to come here and I do positive 5 plus positive 1, I see a 6, right? They didn't give you a symbol, but it's up to you to know that any whole number with no symbol to the left of it is a positive. It's a plus. So that's why we put a plus 6 there. Okay. This one is a no-brainer. It just gets brought down exactly the way it is. Plus 3. And just like that, the long expression that we're given, we just simplified it down to this. A little bit more simpler, still longer. But these are your final answers, my friend. You can't do anything else. There's nothing to combine. We're not given the value of x anywhere. So it's not like we could just bring it into our x's. No. We are done in these specific problems. And on the GED, you might be given, you will be given problems that you need to simplify. I'm trying to see if I could come up with any tips and tricks that you got to be aware of, but I feel like you guys got this. Just focus on your terms, focus on your operations. When you're doing the symbol process, make sure you always include the symbol to the left. Make sure you take it slow, make sure you use the calculator, and make sure on the worksheet you put the correct answers in the format that must be formatted in, with the whole caret sign. For fractions, make sure you use the slash tool, or just anything you can. Make sure you do it correctly. See you on the next one.